Okay, this is the May 2016 IB exam. This is a private YouTube video. It's unlisted, so it's only for the use of the people who I give the link to. And we're going to have a go at question 5. And I'm going to try and do this in real time. So instead of having loaded a load of the answers into it previously, I'm going to try and do it as I would be doing it in the exam. So first of all, there's a little video. Let's have a look at that. Okay, so you've got a rugby ball being kicked. However it's kicked, the path of the ball is always a parabola. Either scoring, so over the posts here, or not going over the crossbar there. You've got a tab with some other information on, so you've got a tab with a successful kick, and you've got a third tab with some formulas on. You've got the axis of symmetry of a parabola. We're not really going to need that because although we're going to need to know where the symmetry axis is, it's kind of intuitive because of the reflective symmetry of a parabola. We've got the good old quadratic formula, and then there's the discriminant, which is basically the square root bit in the quadratic formula. And the reason that's useful is if that's more than 0, then you know you've got something you can solve. But if it's less than 0, then you get the square root of a negative number and you've got something that can't be solved. We're not going to use that for this question though. So it gives you a formula for the height in meters of this particular ball above the ground, and although it looks like a fraction, well, it is a fraction, that's basically a quadratic because you've got an x times a minus x, so that will boil down to something that is something x squared and something x and something that can be rearranged and put equal to 0. So because when you multiply it out, the highest power of x there is x squared, then you've got a quadratic equation. And it says find the maximum height achieved by the ball. So let's just go back to the first bit of the question. The ball is kicked from 0, 0 towards the post and describes the path of a parabola as shown in tab 2. So this is where you might well miss the key information, that it's all about the diagram on tab 2, where the ball starts at 0, 0 and then goes through the air over the crossbar on the post, so it scores, and then it lands 30 units away. So the highest point that it reaches is at 15 units away, because we know that a parabola has that symmetry to it. So we don't need to know the formula for the line of symmetry of a parabola. We can see that it's half of 30, which is 15. So I'm going to write in that the maximum height is when x equals 15, and then we've got to use this formula to find out what that height is when x equals 15. So I'm going to go into the equation editor there. So I've got h of x equals x 30 minus x over 25. So I'm just going to make that expression. So h of x is equal to, and then a fraction there, and then what was it, x 30 minus x over 25, x 30 minus x, close bracket, down to there, over 25, and then I'm going to do the arrow keys to get out of that and do a new line. And then this is where I can save myself a bit of time by being a bit nifty with the Control-C, Control-V. I'm going to copy that from there and paste it down there, so I've got exactly the same thing, but then I'm just going to change that x for a 15. And then it just saves me a little bit of time with clicking on all of the buttons that do formulas. And then I'm going to go on a new line, and I'm going to copy paste the same thing again, but I'm going to simplify it a bit. So 15, that bracket there is 15 because it's 30 minus 15. So I'll just change that for times 15. That doesn't look very good with a cross there, so I think I'll just change that for a proper multiplication sign. 15 times 15 over 25. And then I can get my calculator onto that now. So I'll insert that equation. Takes a bit of time to think about it. And then I'll just go down a bit. And then calculator 15 times 15 is that, and that divided by 25 is 9. So the maximum height is 9. And then if I just close my calculator down and click the calculator icon to insert that, to show how I've done it, and then I'll just write the maximum height is 9 meters. If I've got enough time, I can make that nice and clear and bold and highlighted, but it's not the priority to make it look pretty. The person marking your exam, as long as it's the answers and the methods are there to be found and they're reasonably clear, you're not going to get any extra marks for making it look that bit prettier. So the maximum height is 9. Let's just have a look at this to see if that looks reasonable. Well, it's hard to tell because we don't have the vertical scale on there, but certainly in terms of kicking a ball in the air, 9 meters doesn't seem something unreasonable with our common sense. So that was A. To score points, the ball is kicked from the point 0, 0 and must go over a bar on the posts that is 3 meters above the ground and 26 meters away from the point the ball is kicked. So let's go back to that graph and look at that. So you've got 3 meters above the ground, you've got the crossbar. Let's just go back to the video and remind ourselves what if I can find the video. Where's the video? Tab 1. So there's the rugby goal, and the crossbar is only 3 meters above the ground there. So although the posts are higher, it's got to go over that 3 meter crossbar and between those two posts, in fact, to score the points. So back on tab 2, the crossbar is 3 meters high, which makes our 9 meters for the highest point of the ball look pretty good, doesn't it? So the ball must go over a bar on the post that is 3 meters. I see. So a bar is, yes. So a bar that is 3 meters above the ground and 26 meters away from the point the ball was kicked. So again, I have another look at that, and there it is at 26 meters away from where the ball is kicked. This is illustrated in diagram in tab 2 above. Yeah, we've just looked at that. Remember that the function for the height of the ball is the thing we used before. So the question, show that the team scored points. So we're talking about tab 2. So we can certainly see in the diagram on tab 2 that the ball appears to clear the crossbar. But what we need to do to show that the team scored points is that when x is 26, the height above the ground is more than the 3 meters where the crossbar is. So I'm going to work out what the height is when x is 26. So using the equation, again, I'm going to do a quick bit of cut paste here. So I'm going to take all of that equation box there and copy it and paste it into this other question. But then I'm going to click into it to edit it. So instead of working out the height when x is 15, I'm going to work out the height when x is 26. So I'm working out h of 26, which is equal to 26 times 30 minus 26 over 25, which is equal to 26 times 4 over 25. So I'll insert that equation there. And then again, back to the calculator. So on the calculator, let's just clear all of that from before and move it over. So 26 times 4 divided by 25 is that, 4.16. In fact, I think I'll just go back into my equation there and put in 4.16 because that's just as easy to do. So I'll do a new line and then just copy and paste that, but replace that with 4.16, and there we are. Insert that, close my calculator down. So when the height of the, or when the distance from the original point is 26, the height of the ball, according to the equation, is 4.16. And because it only needs to be 3 meters high to clear the post, then it's a goal. So I just need to make that comment. So since 4.16 is more than 3 meters, the ball clears the crossbar and scores points. And the bit in that that's going to get me the marks is the 4.16 and the comparison with 3 meters. So I'm just going to highlight that bit there that says 4.16 is more than 3, because that's the bit that will be on the mark scheme that the person marking this will be looking for. Later in the game, another kick is taken from the point x0 towards the posts. This time, because it's a different kick, the height of the ball above the ground is represented by a different function, still a quadratic function. Notice that the post cannot be moved. Solve g of x equals to 0. Okay, so quite apart from any context, you've got a quadratic function there, which you've got to put equal to 0 and solve it. So, into the equation editor, and we are trying to solve, I'll put we must solve, and then equation editor. So it's minus x squared, come out of the superscript thing there with the arrow keys, and then what was it? Plus 30x minus 125, plus 30x minus 125, and then all over 25. That's got to be equal to 0. Now I can make that a bit simpler, get rid of the fraction by multiplying both sides by 25. So I'm going to just copy paste that top of the fraction. So copy it there and paste it down there, equals to, well, 0 times 25 is still 0, so multiplying both sides by 25, you just get the top bit equal to 0. So that's now a quadratic equation in the form that we are familiar with. Something x squared plus something x plus something on the end. And then we call those things a, b, and c. So a equals 1 because, minus 1 I should say. A equals minus 1 because we've got minus 1x squared there. We've got b equal to 30 because we've got 30x there. And then c is equal to minus 125 because we've got minus 125 on the end there. So we can solve that with the quadratic formula. So if you don't have that on at your fingertips, at the edge of your brain, there it is. X equals minus b plus or minus square root of b squared minus 4ac over 2a. So we just plug in the a, b, and c to that, and we get the solution for x. So again, I'm going to go into the equation editor and plug in that quadratic formula. X equals fraction and then minus b plus or minus. There's a little button for plus or minus, and then there's a button for square root b superscript squared turn superscript. Oh, I've just turned it on again. What have I done now? Don't want to do that. Let's just come out of that. B squared minus, that's a bit awkward, isn't it? What I'm going to do is get rid of the superscripts I've done. I'm going to type b squared minus 4ac like that with a big 2, and then I'm just going to highlight it and then turn the superscript on there. So that solved my little problems of things not turning off when I click them. B squared minus 4ac all over 2a is the formula. So I'm just going to take that and then I'm going to copy and paste it again, but on the second time I'm going to put in the numbers. So b was 30, so I'll just change all my b's for 30s. 30. A was minus 1, so I'm going to change all my a's for minus 1. So that a there I'll just put in a bracket as minus 1, and then that a on the bottom I'm just going to put in a bracket as minus 1, and then c was minus 125, so I'm just going to take that c and replace it for a bracket that says minus 125, and that's all the numbers in. Next I'm going to simplify this, so I'm going to highlight the whole thing and copy paste it and try and simplify it. I've got minus 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 here, so that's going to come out to be a minus. 30 squared is 30 times 30, which is 900. So you've got minus minus minus, and then 4 times 1 times 125. So 4 times 1 times 125 is 500. So it's going to be minus 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 500. Minus 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 500. 2 minuses make a plus, so 2 of those minuses together cancel each other out. So 400, that comes out to be 400. And then on the bottom, 2 times minus 1 is minus 2. So that's simplified it a bit. I'll just do another line where I simplify it a bit further. So copying it and pasting it, then I'll change that for a 400. Come out of there and do a new line. I can just get out of there. There we are. Square root of 400 is, not surprisingly for an exam question, a nice round value, 20. So we've got minus 30 plus or minus 20 divided by minus 2. Then I think we can just start to evaluate it completely. So minus 30 minus 20 is minus 50, and minus 50 divided by minus 2 is 25. I did all that in my head. You probably want to write some stuff down. Or the other case is where we get minus 30 plus 20, which is minus 10, and minus 10 divided by minus 2, which is 5. So x equals 25 or 5. So let's remember what this question was all about. It was x was how far horizontally along the ground the ball was, and we just figured out when that was equal to 0. So what we've done, going back to these, we've figured out the 2 points where the ball is on the ground at 0. And we've got the answer that the height of the ball was 0 when x equals 25 or 5. And let's have a look at the original question again. Later in the game, another kick is taken from the point x0 towards the posts. Solve g of x equals to 0. Well, we've done the bit that gets us the marks for question C, because the solution is that x equals 25 or 5. But in the context of the question, this means that 5-0 was the point where the ball first started on the ground, and 25-0 was where the ball landed. And if we go back to the diagram of the actual thing, okay, so the ball's been kicked from here at 5-0, it's gone up in the air, and it's landed at 25-0, so it's fallen short of the posts. So the answer to the last bit is that the team did not score points because the ball landed at 25-0, which is short of the posts, let's say. But in questions like this, there's a mixture of things that are routine, so solving a quadratic equation that you've been given, and things that you actually have to think about and place them in the real life context. So it's a question for you in managing your own time, in how you're going to balance your efforts in that kind of question. And if it's me doing this question, I might do the routine bit first, which is solving a quadratic equation, and then maybe come back to that bit when I've got more time, because for 2 marks, it's not a big proportion of the marks, and it actually requires more thought for me than just going straight in and routinely solving a quadratic equation.